Haptic feedback. The technology that makes your touch screen feel real. Defining the sense of digital touch. Haptic feedback is the use of mechanical, electrical, or other physical stimuli to communicate sensations or feelings to a user. On a smartphone, it refers to the precise and varied tactile responses, the taps, clicks, and pulses, that confirm your actions on a completely flat, glass touch screen. This technology is critical because it bridges the gap between the physical and digital worlds. When you tap a virtual button on your screen, haptics creates the illusion of pressing a physical key, making the interaction feel more natural, intuitive, and confident. The Two Actuator Technologies. The physical sensations are generated by a small motor called a haptic actuator or haptic engine inside the phone. The quality of the feedback relies entirely on which type of actuator is used. Eccentric rotating mass (ERM) motors. Older or budget phones often use eccentric rotating mass (ERM) motors. These motors spin a small, unbalanced weight to create vibration. The result is a slow, generalized, and buzzy feeling, similar to a traditional pager or an older phone's alert. They are less precise because the amplitude, strength, and frequency, speed, of the vibration are coupled. Linear resonant actuators, LRAs. Modern, high-end smartphones use linear resonant actuators, LRAs. These motors work by moving a magnetic mass back and forth along a single axis, linear motion, similar to how a speaker works. This design allows for extremely fast start and stop times, measured in milliseconds, and generates a much crisper, more controlled sensation that feels like a sharp tap or click rather than a mushy buzz. The system behind the sensation. Haptic feedback is a complex choreography between the phone's hardware and software. The process happens in milliseconds. Touch detection. The screen digitizer detects your finger press. Software command. The operating system, OS, registers the action, e.g., a keyboard press, a scroll stop, or a navigation button tap. Pattern selection. The OS determines the precise haptic waveform, the duration, intensity, and pattern that corresponds to that action. Actuator execution. The command is sent to the LRA, which moves the internal mass to generate the physical sensation you feel. This coordination allows a phone to use a subtle, short pulse for a keystroke, a more defined double tap for a successful file transfer, or a continuous pattern for a gaming rumble. The impact on user experience. High-quality haptics are no longer a luxury, they are an essential component of the user experience. Action confirmation. Haptics provides immediate physical confirmation that your touch was successfully registered, which is vital for quick typing or rapid navigation. Accessibility. For users with visual impairments, distinct haptic patterns can communicate different alerts or navigation cues without relying on sight or sound. Immersion in gaming. In mobile gaming, haptic feedback adds depth and realism, simulating the recoil of a weapon, the jolt of a collision, or the subtle texture of a virtual surface. Reduced cognitive load. By confirming actions through touch, the user can rely less on visual confirmation, allowing them to type faster and interact more fluidly. The future, HD haptics and texture simulation. The future of haptics involves creating high-definition, HD, tactile experiences. Newer technologies, such as piezoelectric actuators, offer even faster response times and a wider frequency range than LRAs. This allows for the simulation of complex textures, like the feeling of dragging a finger across virtual fabric, paper, or metal on a flat glass screen. As the technology matures, haptic feedback will move beyond simple clicks to become a rich, expressive layer of communication between you and your device.